All right, we're back. We're still on page 8 of math analysis, and we are trying to write angles in terms of, or figure out, the principal coterminal angle, which is the angle within the first revolution, so 0 to 360 or 0 to 2 pi. Trying to figure out from the principal coterminal angle, how many full rotations do you go to get to the angle that you're actually looking for, right? And then we want to figure out the quadrant that we're in, which is actually probably the easiest part. I think the weirdest thing in this table so far, I think you'll probably agree, is this number, which I hate when I double highlight. I don't know why. This number and this number, the negative ones, right? Because they don't really follow the pattern that we maybe thought we were using. We maybe thought, we had 2 and n was 2. We got, I don't know why you would highlight that. We got 17 and 17 was n. And then we got 12 and 12 was n. And then we got negative 1.75 and we thought maybe negative 1 was n, but it was negative 2. So something different is going on there. If you think about how I said it before, though, I said that you start at your principal coterminal angle. So here for 90 degrees, right? So we're going to start at 90 degrees. So start here. From there, what are we going to do? We're going to rotate 2 revolutions clockwise because n is negative. So 2 clockwise revolutions. So you could think of that, right? You start at 90, so you rotate 90. And then from there, you go negative 1, negative 2, and you end, okay. This is killing me today. It's like the 3rd time I've tried to make this video because it keeps freezing on me. Really excited about that. 1, 2, right? So that's one way of thinking about it. Another way of thinking about it, and I think it's the better way. Well, I think it's the better way. It doesn't really matter if it is or isn't. We could start with, okay, start at 0. For all of them, you can think of it this way. Start at 0, rotate however many full revolutions you're supposed to, and then rotate the principal coterminal angle. That's how I actually choose to think about it. So for 90 to end up at negative 630, right, this row, what I'm going to do, I'm going to start at 0. I'm going to go 2 negative revolutions. So I'll use a different color for this. Here's 1, here's 2, right? I've gone 2 negative revolutions. So that was that way. Let me put like this. Then from there, I'm going to rotate back the 90 here, right? So what we do is instead of going the full 2 revolutions, so the actual angle that we're graphing, or the actual rotation that we're doing to get there, is you go here, and you just stop when you get here. Coterminal, they end in the same place. So we could do the same thing for negative 7430, except nobody wants to rotate negative 21 times, right? But I would start at 0. I'd rotate 21 times clockwise. Once I'm done with that, I would then rotate 130 degrees counterclockwise. Wherever I end up there, that's where I wanted to stop. It's like you overshot when you rotated. So that's one way of thinking of it. That's how I choose to think about the negatives. All right, let's do these with radians and see how there's like no difference really. So we're going to divide by 2 pi. You do want to be careful on your calculator though, and I'll show you that in a second, or in a minute, or in some amount of time. All right, so I'm dividing by 2 pi. Use the fraction templates. I did this ahead of time. I got 1.833. Okay, so that means I'm thinking that n is 1. Because when it's positive, we're not having an issue here. And then if I do 11 pi over 3 minus 1 times, so if it's over 3, you want to think of 2 pi as 6 pi over 3, and then that'll give me 5 pi over 3. So 5 pi over 3 is my principal coterminal angle, and then that I know is in quadrant 4 because I memorized all the famous angles and where they are, and you should do that too. Another way of thinking of it, it's like almost 2 pi, so it should be like in the quadrant that's really close to getting to 2 pi, so it should be in the 4th quadrant. All right, let's try this. Over 4 divided by 2 pi. That's going to be 3.3, actually it's exact. So it's exactly 3.375. Okay, so that 3.375 tells me that I'm going to be in quadrant 2, right? Because it's 0 to 0.25 revolutions, 0.25 to 0.5 revolutions is quadrant 2. Then you keep going, but we already hit the quadrant we need. So we get this. All right, so I want to do 27 pi over 4. And then I want to subtract 3 times. What's 2 pi when you're doing over 4? So it's 8 pi over 4. 8 pi over 4. So that's 27 minus 24 is 3 pi over 4. So that's A, 3 pi over 4. All right, let's try the next one. 26 pi over 5 all over 2 pi, which is going to be approximately 2. No, it's exactly. These radian ones keep coming up exact, 2.6. So I want to do, so 0.6 I know is in quadrant 3 because it's past 0.5 but not to 0.75, so quadrant 3. All right, let's do 26 pi over 5. Then we're going to subtract 2 times. 2 pi written in fifths is 10 pi over 5. Kind of forgot what I was doing halfway through that. 26 minus 20 is 6 pi over 5, which is like a little more than pi, so it makes sense to me that it's in the second quadrant. Oh, look at me forgetting to fill in things. So here n is 3, here n is 2. This is 6 pi over 5. All right, and the sort of dreaded negatives, right? Because they're just not working the same way, and we want to figure out why that is, but not the time. Almost the time, though. All right, this one's definitely a decimal. Negative 1.417, negative 1.417. And I had worked these out ahead of time in actually in a spreadsheet, so that I wasn't going to make you watch me type all of these into the calculator. That's why I'm, occasionally looking up as if I'm stealing answers from somewhere. It's because I am. Okay, so we know that negative 1 won't work for some reason. So we're going to use negative 2. And so I'm going to do plus, so it's plus this time. It's minus really, negative 2 times 2 pi, but I'm going to write 12 pi over 6. So you're always doing minus n. If n is negative, you're still doing minus n. It's just minus a negative is plus. So we get 24 minus 17 is 7 pi over 6. Famous angle alert. 7 pi over 6 is A. And then that's definitely in quadrant 3. Ew, 3. Okay, and we're done. So this is another weird one. So let's highlight it again. What color are we using for that? I think this color. It's another weird one. The negatives, always a little weirder. But all of these have been written in terms of their principal coterminal angles. That's great. So what I want to do is I want to show you how I was doing these on the calculator to make sure that you can do the radian ones on the calculator as well. And then I might come back in another video and talk more about the calculator because first of all, the calculator frequently makes the video just stop working, and it's really frustrating. So I don't know if I want to risk my long video here on the calculator messing it up. All right, so I want to do the 11 pi over 3. So I'm going to put it in parentheses. It doesn't need to be, but it should be a fraction. 11 pi over 3. Remember, you have a pi key down here. You should use it. Faster for me to type it. And then I want to divide this by 2 pi. Anytime you use a fraction on the Inspire, use the fraction template. Don't risk it. Let me show you what happens. So, and then I'm going to do Control Enter. Otherwise, it gives me the exact. So if I mess this up and I try to do like 11 pi over 3 divided by maybe like 2 pi, like no fraction template, look at how it interprets that. It interprets it correctly, right? I divided by 2, I multiplied by pi. That's not what I wanted. So use your fraction templates always. So for these, we could figure out like, we could write a function almost that gives us n, like almost. We'd say like n of x, where x is going to be the angle that we're using. It's just going to be x divided by 2 pi, except it's not. It's like almost that, right? And then, so I can do n of 11 pi over 3, and I get this, but I want the decimal. I can do n of 27 pi over 4, which I should use the fraction template, so let me delete that. 27 pi over 4, Control Enter, n of 26 pi over 5, Control Enter, I get this. So this is working. The problem is here, negative 17 pi over 6. Could just put a decimal down here, and it'll give me the decimal. That gives me negative 1.417, but I want n to be negative 2. So I got to think this through a little more. We could also, though, like, once we know what n is, we could figure out a. There's like some clever things we can do here, and the next video I'm going to talk about this more, but I know that a is just going to be whatever x was, and then I want to subtract n for that particular x times 2 pi. So this is going to work. Watch this. Do a of 11 pi over 3. And what? Why am I getting that? And oh, it's because we didn't talk about the thing we need to talk about yet. This isn't working at all. We can't do that yet. All right. You know what I'm going to do? I'm going to stop this video here and come back in the next video and actually talk about the thing that I think I'm talking about without talking about it right now. So I will be back in the next video. And in the next video, we're going to talk a lot more about n. And once we figure out what's going on with that, then we're going to do that formula. So I apologize. I didn't know what I was talking about there. This happens all the time in my live classes. It just doesn't happen as often on video because I don't really know. I'm a little less distracted maybe when I'm making the videos. But anyway, I'll see you in the next one when we're going to finally settle this n thing. What is happening here? All right, so I will see you in that video.